Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start our studies on solving questions on hypothesis testing. Basically, it will focus on the definitions on the hypothesis testing for one sample t-test, where we have our t-test and our z-test, and many more. So stay tuned and we are going to solve more questions on statistical method 2 and biostatistics 2 for the biological science and social science students in Kenya University and the rest of the campuses. So question one, please, I'm coming. So question one is saying that a statement made about a population for testing purpose is called A, statistics, B, hypothesis, C, level of significance, D, test statistics. The answer is what? B, that's hypothesis. Usually, a hypothesis is just making claim or statement about the population parameters. So once we make a claim or statement about the population parameters, then we are talking about hypothesis, right? B, second. The second question is, if the assumed hypothesis is tested for rejection, considering it to be true, is called A, null hypothesis. B, statistical hypothesis. No, statistical hypothesis also talks about using the sample to test about the population. The sample hypothesis, no. Composite hypothesis, no. So the correct answer here is what? The null hypothesis. 3. A statement whose validity is tested on the basis of a sample is called statistical hypothesis, right? So statistical hypothesis, that's answer B, right? So null hypothesis is not used to test for that, right? And then sample blah blah is not used to test. The only one that you can use to test is what? The statistical hypothesis. I told you guys that for statistical, those who follow my channel on hypothesis testing, I told you that for statistical hypothesis and hypothesis, just like for the statistical hypothesis, we are just using a sample to test a claim about the population, right? So that's the 3. Answer 3 is what? B. Question 3 is B, sorry. And for question 4, a hypothesis who defines the population distribution is called, right? Hypothesis which defines the population distribution is called simple hypothesis. It's going to describe the population distribution for you, whether it's normally distributed, whether it's T distributed, or many more. And for question 5, the rejection probability of null hypothesis when it is true is called the level of what? Significance. That's answer B. The point where the null hypothesis gets rejected is called the critical region. It's true because for you see, we have, let's say, normal distribution like this, right? And here will be what? Our critical value. For us to be able to reject H0 or for us to be able to accept H0, it depends on what? The critical value, right? When our calculated value falls in the rejection rate, we are going to reject. When it falls here, we are going to what? Fail to what? Reject. So the critical value, as you can see here, help us to know if you are rejecting H0 or not. Yes. So that's answer D. Question 7 said, if the critical region is evenly distributed, if the critical region is evenly distributed, then the test is referred to as two-tailed test. Yes, because if you have evenly distributed, it means that we are having this distribution. We have our tail to the left and tail to the right. So once you have your tail to the left and tail to the right, they are evenly distributed, and here our concentration will be talking about the two-tailed test. So that is that for the question 7. Question 8 says, the type of test is defined by which of the following? The type of test is defined by which of the, for you to be able to know that if this test is a right tail test, a two-tail test, or a left tail test, it depends on what the alternative hypothesis. When the alternative hypothesis is equal to two-tail, when it is less than left tail, when it is greater than, it's a right tail test, right? So our answer here is answer C. Answer C. That's for question 8. Question 9. Question 9 says, which of the following is defined as a rule or formula to test a null hypothesis? That's the test statistics, right? We don't use the population statistics, variance statistics, and null statistics. No, that's the test statistics that you use to do that. Question 10. Consider a hypothesis H0 where our phi naught is equal to 5 against phi 1 where our against h1 where our phi 1 is greater than 5. The test is, so you see, this is alternative hypothesis and this is null hypothesis. For us to know that this is a right tail, left tail, or truth tail, we use the alternative. And the alternative is carrying what? A greater than sign. So here our test is what? A right tail test. That's for question 10. Question 11 says the same thing, right? Here we are having less than sign here. So once we have less than sign here, it's also what? A left tail. And question 12 said, consider a hypothesis where h naught, where our phi naught is equal to 23 against phi 1 is less than 23. The test is what? A left tail test, since we are having a less than sign here, right? Yes. Question 13, we have type 1 error occurs when we reject, type 1 error occurs when we reject h naught if it is true, right? That is it, right? So we will having a type 1 error when our h naught is true, but we are what? Rejecting it, right? It's just like when a boy proposed to a girl, right? Indeed, the girl really likes the boy, right? But the tradition of the ladies is that when a man comes to you and then proposes to you, you shouldn't accept it that same day. So even though they like the person, some will try to reject them in one way or the other to see if the guy really loves them, blah blah blah. So you rejecting the guy is what? Type 1 error. So for type 1 error, it's just rejecting h naught if it is true, right? Yes. So for question 14, the probability of type 1 error is referred to as what? Our alpha, right? The probability of type 1 error is referred to as what? Alpha. That's a significant level. Question 50 said, the alternative hypothesis is also called as what? Research hypothesis. Yes, alternative is also called research, because for research, when you embark on the research, you are either going to accept your findings, you are going to fail to accept your finding based on your alternative hypothesis. Question 16, it said the t-test is used to compare. You see, t-test is used to compare means, right? That's the reason why we have hypothesis testing for the population mean. Under the hypothesis testing for the population mean, that is where we have the t-test and the z-test. And then for t-test, we have one sample t-test and we have two sample t-tests. So when we are working on two sample t-tests, our main focus is to compare. Sample mean of two groups. So that's answer C, right? So let's continue. Said the t-test is based on a test statistics, which is the ratio of what? Two sample mean, right? You are going to base on a ratio of two sample mean. Always note that the t-test and the z-test are always for what? The mean. So that's answer A. Question 18. When the sample size increases, the z distribution approaches what? A normal distribution, right? So when our sample size continues to increase, our z distribution follows what? A normal distribution, not a binomial distribution and a uniform distribution, but what? A normal distribution. The t-test assume that the data is what? Normally distributed, right? So for t-test, I told you guys that when let's say this is our t distribution, but when our n continue to increases, you could see that our t distribution is what? Usually what? Approximately what? Distributed. So we assume that for data for t distribution, it is what? Normally what? Distributed. That is for question 19A. For question 20, what assumption must be met for the t-test to be valid? A. The data must follow a uniform distribution, of which it is wrong. B. The population variance should be what? Equal. C. The sample must be equal. So here our answer is what? B. The population variance should what? Equal. So for the test for that, we just assume two things, right? Our the sample must be randomly distributed. Our population standard deviation must be unknown, and then the variances must be what? Equal. Of which our answer for the question 20 is B. For question 21, which of the following describe the null hypothesis in a t-test? Said, which of the following describes the null hypothesis in a t-test? So A, the sample median is greater than the population median. B, the mean of the two groups are equal. C, the sample variances are equal. So for the null hypothesis, we assume that the means are equal. So that's answer B. What is the effect of increasing a sample size on a t statistics in a t-test? When we increase the sample size, the t statistics increase, or the test statistics increases, right? So that's answer B. If you conduct a sample t-test with a sample mean of 100, the population mean of 95, the standard deviation of 10, and the sample size of 25, what is the test statistics? So let's solve this question. So right now we have our parameters down. We have our x bar to be 100. We have our mu to be 95. We have our standard deviation to be 10. Sorry, that's population standard deviation. So we have our standard deviation to be 10, and then our n to be 25. Right? Yes. So those of you who watch my videos on hypothesis testing for z-test, I told you that, you see, for us to be able to use a z-test, right, our population standard deviation must be known, of which it is known here. So once our population standard deviation is known here, we don't pay attention to our n. Whether our n is greater than 30 or our n is less than 30, we are still going to use our z-test. So here we know that our z-test is equal to x bar minus mu sigma square root of n, which is equal to 100 minus 95 divided by 10 square root of 25, of which you are going to get 100 minus 95 is 5 divided by 10 divided by 5, because square root of 25 is 5. This one will cancel that. You are going to get 2.5. So we have been asked to give them what is the test statistics, and here our test statistics here is 2.5. So let's jump to question 24. The question 24 is saying the z-test is used to compare two sample mean for dependent groups, two sample proportion for independent groups, two sample mean for independent group. So we are using our t-test to just check the proportions for the dependent groups. That is answer B, right? Let's continue. Question 25 reads, I'm coming. Question 25 reads, the z-test is based on z-score, which is the ratio of the difference between the sample proportion and the standard deviation of the difference. Ratio of two samples. No. The z-test is based on z-score of this one. That's A. Answer A. Answer question 26. The z-test assumes that the population variance is known. Right? Yes. In the normal circumstance, I said our population standard deviation must be known. But when our population standard deviation is known and we take square of the population standard deviation, we are getting a population variance. So population variance must be known for the z-test. The test is commonly used when comparing proportion in which type of data, that's categorical data. We use it to compare categorical data for the test. Question 28 says, using the z table, find the critical value of each of the alpha values given below. Use the statement to answer the above question. The question below. Yes. So for question 28 is the 29 here is supposed to be 28, but let's take it like that. 29, right? So we are just saying that when our alpha is equal to 0.10 and it is t-test, right? We have to just calculate for the z-score for that. The critical value for that, right? So when it is two-tailed test, right? We are going to have z subscript alpha divided by 2, which will give us z of 0.10 divided by 2. We are going to get z subscript 0.05, and this one is on the negative table. So if you want it on the positive table, you have to just subtract 1 from it. So you are going to get z subscript 1 minus 0.05, of which you are getting z subscript 0.95. And when you go straight to the z table with these probabilities, you are going to get our z-score to be 1.96, right? And for our z of 0.05, we are going to also get z subscript 0.05 divided by 2. Or we are getting z subscript 0.025. Subtract 1 from it, we are going to get z of 0.975. When we go straight to this t table and find this one, we are going to get the z score for that. We are going to get 1.96. 1.96. And I think for the question 30 says when our alpha is equal to 0.01 and it is a two-tailed test. For this one too, we are going to get z subscript 0.01 divided by 2, where we get z subscript 0.005. We are getting 0.995. So for this one, I'm going to look at from the table, and your final answer for that one too will be given as 2.58. As you can see here, 2.58 will be what your final answer. So let's go to our next question. This is a preamble that you are going to use to, so this is a preamble that we are going to use to solve question 31 to question 35. So he said, a researcher believes that the mean age of medical doctors in a large hospital system is 14 to 15, older than the average age of doctors in the United States, which is 46. Assume the population standard deviation is 42. A random sample of 30 doctors from the system is selected, and the mean age of the sample is 48.6. Test the claim at alpha of 0.05. So we are to use this preamble to answer question 31 to 35. So here, 31 said, what is the population mean? What is the population mean? From the preamble, we could see clearly that our population mean here is what? 46. So let's deduce that there so that solving this question will be very simple for us. We know that our population standard deviation will be 46, right? Population mean will be what? 46. Population standard deviation population standard deviation will be 4.2, and our x bar will be what? Our x bar, that's the sample mean, will be what? Our sample mean will be 48.6, and our n will be 30, and then you have that's that. So the population mean here will be what? 46. We just circle this one. That's answer A. And then what is, I think the question has repeated twice. So I think here was the sample mean. So here was what? The sample mean. So for the sample mean for this question, we are going to have we are going to have 48, right? 48.6, and I don't think there is an answer here, but that is the answer. 48.6 will be the sample mean, and the sample size will be what? The sample size will be 20, as we have there. Our sample size will be 20, and then we have been asked to compute for the test statistics, right? We have been asked to compute for the test statistics, and we know we are using our z-test to compute the test statistics, right? Our distance is 30. The sample size is 30. So please, that answer, for that question, the answer is 30. For the sample size 1, the answer is what? 30. And then we have been asked to calculate for the test statistics, right? And the critical value. That one I will leave for you guys as an assignment. Do it and share it at the comment section. Question 34 and then question 35. Use that as an assignment and solve it. Share your answer at the comment section below, and then I will answer you. So let's jump to question 35. So for question 35, we are saying if our p value is less than alpha, what are we assuming? Are we rejecting h naught, or we are going to fail to reject h naught? When our p value is less than alpha, we reject the null hypothesis, right? So put it at back of your head that we reject our null hypothesis. And for question 36, if our p value is greater than alpha, we do not reject the null hypothesis, right? It means that we are having a strong claim about that one, right? We said find a critical value, critical t value for alpha of 0.05 if our degrees of freedom is 16 for a right tail test, right? So for this one, we are going to calculate for our critical value for this t distribution, and this is a one tilted because it is still to the right. We have t subscript alpha comma n minus 1, but for here the degrees of freedom is already given to us. We are not going to subtract 1 from the n, so here will be t subscript 0.05 comma 16. We are going straight to the table and locate where we can see 0.05 and then 16 on the t distribution table. So let's go. So on the t distribution table, we have 0.05, which is one tail test. We are going to locate what 16 as our degrees of freedom, of which we are getting 1.746. That will be our answer, 1.746. So 1.746 is here. That will be our answer. That's answer A. Question 38 is saying find the critical t value for alpha which is equal to 0.01 with a degrees of freedom of 24 for a left tail test. This is also a left tail test. So since it's a left tail test, we have t subscript alpha n minus 1, but fortunately we have been given 24 to be the degrees of freedom, so we are not going to subtract 1 from it, right? So here will be t subscript 0.01 comma 24, and then when we go straight to the t table to find, we are going to get negative 2.49, negative 2.492. So let's continue. This is a preamble. It says a researcher found that a cigarette smoker smokes on average 31 cigarettes a day. She feels that this average is too high. She selected a random sample of 10 smokers and found that the mean of the cigarettes they smoke per day was 28. The sample standard deviation was 2.7 at an alpha of 0.05. Is there enough evidence to support this claim? So we are going to test that, and then we are going to use this one to answer the questions that follows, right? Yes. So let's write down our parameters. We have our mean to be 31, that's the population mean. We have our sample mean to be 28, and then we have our sample to be 10, right? Our n will be equal to 10, and then we have our s to be equal to 2.7. Our alpha is given as 0.05. So here the question says, what is the population mean? Which is very simple, 31. We have it here. What the standard deviation? 2.7, of which we have it here, 2.7. What the sample size, of which we have it here, that is what, 10. So I think that is all for this question. So let's go to question 42. So 42 is saying the point where the null hypothesis gets rejected is called a critical value, right? I've explained this before. A pair t test consists of n pair of observation. What is the number of degrees of freedom of the test? The pair test consists of n pairs of observation. What is the number of degrees of freedom of the test? So if we want to calculate for the degrees of freedom for a t-test, we have the degrees of freedom is what? N minus 1. Which of the following represent the confidence coefficient, right? So for us to get a confidence interval, that's our C. Our C, confidence interval, is equal to 1 minus 1 alpha, which is answer what? A. And for question 45, we are having question 45. It says the independent values in a set of values of a test is called the degrees of freedom. That's the values that we have in a test. That's the independent of an observation. That's what the degrees of freedom. And then 47 says a t-test sample has 7 pairs of samples. The distribution should contain 6 degrees of freedom. If you have n minus 1 degrees of freedom, if you have n to be 7, our degrees of freedom will be 7 minus 1. 48 is a researcher reports that the average salary of assistant professor is more than $42,000. A sample of 30 assistant professors has a mean salary of $43,260. At an alpha of 0.05, test the claim that assistant professor earn more than $42,000 per year. The standard deviation of the population is 5,230. So we have to test this claim, right? And for this claim, what we are interested is just to give the test statistics of the claim, right? Yes, so here we have our meal to be 42,000, and then our X bar to be $43,260, and then we have our X to be 5,230, and then we have our N to be 30 professors, and our alpha wasn't given, right? Yes, but we assume it to be 0.05, right? So here we have our population standard deviation, and then our N is greater than, our N is 30, so we can use our Z test to solve this question. So here we have Z be equal to our X bar minus mu divided by square root of N, which will give us 43,260 minus 42,000 US dollars divided by 5230 square root of 30. When you do your calculation very well, we are going to get 1.32. So here will be our answer, 1.32 for the above question. And for question 49, said educator claims that the average salary of a substitute teacher in a school district in that country, Pennsylvania, is less than 60 per a day. The sample standard deviation, the sample of a school's district has a mean of 58.8, a standard deviation of 5.08. Is there enough evidence? So we are not testing it, but we are just calculating for the test statistics, right? Yes. And right now, I'll leave this question for you as an assignment. Right now, you owe me 3 assignments. Yes, for the question 49, solve it and share it at the comment section. We are going to use the t-test to solve, right? And then question 50 says the independent values in a set of value of a test is called the level of. The independent values in a set of value of a test, it's not called the level of confidence, but rather it's called what? The degrees of what? Freedom. That's answer A. So this is Statistics and Mathematics YouTube channel. Please, those of you who haven't subscribed, kindly subscribe, like and share so that this video will get viral for your friends to also watch. But don't forget to leave your comments below, okay? Yes, if you think this video really helps you to really get enough understanding on the hypothesis testing, kindly leave a comment at the section below for me to watch on it. Thank you for watching once again. Have a great day. Bye.